1. What can I help you with?
Number 4.
Number 4? You got it. All right. Number 4. Thank you for asking about this one. So they have this particular point, and then they have the two inequalities. So if they give you the point and the inequalities, and they just want to know if that's a solution, you do not need to go and graph it to see if it happens to be in the shaded region. What you do is you just take this x and y value and plug it into the x and y's on both equations. So that's going to give me negative 4 is greater than negative 12 plus 5, because 3 times negative 4 is negative 4, a larger number than negative 7. Is that true or false? Would you rather owe $4 or $7? 4. So this is true. Okay? So if it's true on one, that's great. But that doesn't mean that it's truly part of the solution. You have to plug it into the other one. Plug negative 4 into both. 1/2 times negative 4 plus 6 is negative 4 less than negative 2 plus 6 is negative 4 less than positive 4. So it's true on both. It's true on both. So yes, this is a solution of the problem. Okay? Meaning if I had graphed these, the point negative 4, if I had graphed it, so that point right down here would be somehow part of the shaded region. So you have a shaded region somewhere like this. I don't know what the graphs look like because I didn't graph them, but it means it's part of that shaded region. What else did you see on page 221 that I can help you with? Look carefully while I go get my copy.
Number 11.
Number 11?
Yes.
Okay. Number 11. Ooh, it's a graphing one. Okay. Number 11. What you doing there, Jack?
Clicking my pen.
Okay, so we want to graph this one. Okay. How are these set up to graph? Do we know the y-intercept and the slope by looking at them?
Yes. Wait.
No.
I was going to say, you're pretty smart if you know the y-intercept and the slope just by looking at them. How are these set up to graph? Do the cover method. Thank you. No way. Just have a seat in that chair. You'll be all right. We were making fun of you. I take back everything I said against her, and whatever you say I said against her is a blatant lie.
Whatever. Did you know what he said to me when I texted him that I was going to be out sick? He said, you called me a wimp.
Yeah.
And that's when you got her.
A wimp. No, it's okay.
Yeah,
And then he was
you
like,
know.
oh, have you guys ever seen The Price is Right? Stop.
Yeah.
They haven't even seen it. It's like the
I've
sad
seen The
thing.
Price is Right.
Okay, but then I told him, hey, it's not on Netflix.
Oh,
Because I have no TV.
All right. Well, we're happy you're here.
Thanks, Buzz.
All right. So this is an x value, yes?
No, I.
So this is going to say that 4y equals 12, so y equals 3. So 0, 3. And then this one is a y value, so then that's going to give me 2x equals 12. Divide each side by that, so I get 6. So 6 comma 0.
No, 11.
Solid or dotted? Dotted. There's not a line underneath, so that makes it dotted, right? Woo. Hey, friends, if you look at this, does it make sense that 0, 0 is definitely on the lower left-hand portion of the dotted line? See where our test point's going to be? So that's still going to work. Okay, let's take a look at the other one. Ooh, I'm going to pink. I want pink. I like pink. All right. So this one's also set up as cover method. All right, so that's an x value. So let's solve that. I get negative 5y equals negative 10. Divide both sides by negative 5, so y equals 2. And then that's a y value, so that's going to give me negative 10x equals negative 10. Divide each side by negative 10, so I get 1. All right, so 0, 2 is there. 1, 0 is here. Solid or dotted, friends? Solid. I got that line right there, so I got a solid line. All right, let's see if we can graph this. Graph it the best we can. Does 0, 0 still appear to be a good point to pick? I think so. I mean, it's right here. So that's what we're going to test. Okay, so if I plug 0, 0 in, the nice thing is in the cover method, take a look at this. If I plug 0 in for both of those, what do I get on the left side of that equation? If I plug 0 in for the x and 0 in for the y, what do I get on the left side? 0. Is 0 greater than 12? No. So this one is the blue equation. So that means I'm going to shade the top portion of the blue. Okay. Now we have to do the same thing. Now, nice thing is, cover method is going to work nicely. If I take 0, 0 and plug it in for the x and the y, what do I get on the left side? I get 0. Is 0 less than or equal to negative 10? No, this is false as well. So that means I shade the top side of the green, or the pink, I'm sorry, with using green. All right, so my shaded region on this problem is this region here. Okay, that's where my solution lives. What else did we see on page 221 that I could help you with? 9? I could do that. Do you all see how like Stone got here conveniently after I had taken attendance, put grades in for your homework? Unbelievable. Unbelievable. Like I cried myself to sleep.
You do love tea.
Oh, hey, so number 9, hey friends, do me a favor. On number 9, we're going to skip it. The reason I'm going to skip it is what do you see wrong with this? We made a misprint. So, yeah, we made a misprint. You know, we're not perfect. Never claimed to be. All right, all right. All good in the hood? All right. So, my friends, let's take a good look at page 223. And I'm going to look at problem number 1. Watch the language back there. I'm recording. I am. All right. So this is not a shading problem. How do we know? Yeah, I don't have an inequality sign, right? They're equal to each other. So we want to solve these. Agree? We're going to solve this. So if we're going to solve it, talk to me, friends. How am I going to start solving this? And looking on your neighbor's paper isn't the way.
Plug in x plus 5.
Yeah, I'm going to use the substitution method. I'm going to take x plus 5, and I am going to put it into... Ooh, green first one. What did I do? I laugh when people fall. You all know that. All right, ready? This is what was suggested to do. What do you think, friends? Does that seem like a legitimate thing to do? Okay. So I get negative 10x plus 35. This is where y used to live. Y no longer lives there. We're moving in our new friends, the x plus 5 folks. Okay? Distribute. Let's see, 35 times 5. 5 times 5, 25. Carry 2. 15, 175 equals 300. Combine like terms. Seems like really big numbers, but I think it's going to work out nicely. Hmm, 125. How do I get x by itself at that point? Divide, good. X equals 5. Is the problem done when we get to that point?
No.
No.
No. You gotta get Y.
Got to get the y. So I'm going to take this 5, and I'm going to replace it for x. So I'm going to do it on the top one or the bottom one. They're the same answer regardless. Which one looks simpler? Top, yeah. Done. Okay. Questions about that one? So substitution is a method used to solve these. Agree? All right. May I move on? Did you get this copied down on page 223? Did anyone forget to copy it down?
Nope.
We're good?
I think he's recording.
Huh?
I think he's recording.
Yeah, buddy. And I got lifesavers, so best day ever. All right. Let's take a look at problem number 3. Hope so. All right. Friends, substitution or not?
No, elimination.
Elimination, good job. Give me some notes. Boom, blowing it up. Okay. We're going to do elimination, aka the addition method. So, friends, if I add these together, do one of the letters go bye-bye? If I add 17 or 7x and 9x, I get 16x. If I add negative 4 and negative 5y, I get negative 9y. So I have to figure out something to do to both.
I was gonna do the top equation times negative 5 and the bottom by 4.
Negative 5 and the bottom by 4. Let's see. So this was just suggested to me. Let's see what happens here. I'm just curious. I don't know if this is going to work or not, but I like the thought. I like this. Bless you. I like this. And it's still equal to 0, so I really like that. And that's going to give me, what, 36x minus 20y equals 4. I don't know. Jack might have been on to something, but I think he's wrong. Because negative 35x plus 36x is x. Oh, those cancel out. Ooh, I retract my statement. Jack was correct. Good deal. All right. So far I get 4 comma something. Agree? Is the problem done? Yeah, I got to take this 4. I got to take this 4, and I got to plug it into the x on either of these. I don't know if it really matters which one I do.
Damn.
All right. I'm going to take the top one. 7. This was x. X is no longer there. What's going to go in where this x was? 4. Good. 28 minus 4y equals 0. Solve the problem. Canceled. Negative 4y equals negative 28. Help me out, friends.
Absolutely correct.
How should I, who? Divided by negative 4. Good. Hey, do I flip the equal sign over? It's like, no, stir up. Equal signs don't flip. Silly. So I get a solution to that. Huh. All right. Your choice, friends. Of the remaining 1 through 9, of the remaining 1 through 9, which other one would you like to look at?
7.
7 was the first one I heard. I'm gonna go with it.
7 and 5.
All right, we'll do 7. Because if we do 7, I bet you we could do 5. All right. So I know that we have a fraction, but let's not be totally afraid of the fraction. How should I do this problem? Should we do it as elimination or substitution?
Substitution.
Why? I like your thought. Why?
Because I don't know, that was
Because what?
that came to my head.
Because I don't know.
You're saying it.
No, because
You're saying it.
X equals.
Oh, that's it.
Ah.
Because we have x equals something, I can replace this here. Okay? So let's just bring it down. All right, where those parentheses live right now is where x used to live, but now the negative 1/2 y's plus 4 are moving in. Okay, I think we can handle this. What is half of 8? 4. What is negative half of 8? Negative 4. And then plus 32 plus 31 equals 31. Those are like terms. Negative 1y, very good. Or just negative y, you could put it as well. I like it. Subtract 32.
62 negative.
Do what?
Wait. No. That's it. Oh, it looks weird. That's why.
Am I done?
No.
What should I do with this 1? Plug it in where? Which one looks better? Bottom one, because I'm looking for an x equation. Good. Okay, where the parentheses are is where 4 lived. Who's moving in? 1. Blessing you. Ooh. This is like 3 1/2. Yowzers. Good luck for graphing that one. All right.
5.
Nope, already did it. We already chose 7. All right. Flip it over. Flip it over. Let's go to page 224. 224. I'm going to do number 14. Now, Syrup is doing this without a net. We're going to be really careful. Number 14. All right. Here we go. What's my y-intercept of the pink?
Negative 1/1.
That's the slope.
1.
0, comma, positive 1. Okay, right there. Slope is negative 1/1. So down 1, right 1. Hey, is this a solid or a dotted line?
Solid.
Solid. It's an equal sign, right? It's got to be solid.
Like shell.
Okay. I think we need another fancy color. Ooh. Oh, that's not. I like that purple. Oh, look at the purple. Hey, what's the y-intercept of the purple? Yep, 0, -5. Good. Me too. What's my slope?
1/2.
Okay. Up 1, right 2. up one, right, 2. Okay, that boxed in region appears to be the point 3, comma, negative 3. This is my solution. Ooh, baby. Okay. The only thing different that we started with is we started graphing inequalities. So why did we not shade anything on this graph?
Because there's no, what's it called?
What is it called?
What's the sign?
They're equal signs. They're not inequalities. They're equal signs. All right, my friends, I would like you to work on page 223 and 224. And I think if you do...
Let's do odd.
Okay.
No,
Yeah.
what if he's gonna give us like 5 items?
All right. Hey, guys and girls, let's show Miss Stone how well we all worked as a class together and got things done from yesterday. Oh, wait, there was a few of you that didn't.